Hello class, this is topic 8-4 with Algebra 2. These are the notes. And today we're going to talk about rational and cubic functions. So here we have our rational function. And down here for number 2 we have our cubic. So let's go ahead and discuss our parent functions. Starting with the rational. I'm going to go ahead and pick some x's that will make sense here in a little bit as we fill them in. I want to go with -2, -1, -1/2, then 1/2, 1, and 2. So, as I find my y values for these, we're going to go ahead and mark these. So 1 over -2, that's -1/2. 1 over -1, -1. 1 over -1/2, well, that comes out to -2. 1 over 1/2 is +2. 1 over 1 is 1, and 1 over 2 is 1/2. I'm going to go ahead and graph these points, and I'm going to go ahead and use a different color to graph them today because I want to make sure that you understand where these points fall. Our first point at -2, -1/2 lies here. -1, -1, and -1/2, -2. And then 1/2, 2, 1, 1, and 2, 1/2. Well, you'll notice these points don't seem to make a single line. In fact, they don't. They make a pair of lines with some asymptotes in between. I'm going to use a blue highlighter to mark them. We have one asymptote right here. It never actually hits the x-axis, and it never actually hits the y-axis. You can just use dashed lines to represent these on your paper. What our graph actually does is it comes in very, very close to 0. And it swoops out to hit our 3 points. And then it hugs the x-axis all the way to infinity. It never actually crosses. And on the other side, it swoops in from infinity, swings out just wide enough to run through our points, and then hugs 0, never actually crossing it. Okay? So we have basically a bare space here at the x-axis and a bare space here at the y-axis. Those are called asymptotes. So a vertical asymptote is at x equals 0. A horizontal is at y equals 0. So if we talk domain and range, well, domain, we do go all the way forever left. We go all the way forever right, but we don't hit 0. So we're just going to put that x cannot equal 0. Notice that's very similar to our vertical asymptote. Our range, well, we go forever from the top, forever to the bottom, except we never hit 0. So y cannot equal 0. Notice that these have been pulled directly from our asymptotes. Where our asymptotes are, that's where our domain and range cannot be. Let's go ahead and move on to our cubic. Now, this is cubic function extremely simplified. They can get a lot more complicated than this, but just going off of the parent function, here's some things that we can do. I'm going to use x values of -2, -1, 0, 1, and 2. My f of x values, my y values would be -8, negative 1, 0, 1, and positive 8. If I come over and I graph these, negative 2, negative 8, negative 1, negative 1, 0, 0, and 2, 8. So we swoop in very, very steeply. We're still very, very steep. We eventually curve. We got to plot 1, 1. We curve in. And we get very steep again. If we were to like zoom in on this section right here, it actually gets flat right here at our center point. Okay? It actually zooms in, gets flat, and goes back up again. So I know that's kind of hard to draw in such a limited space, but that's basically what it does. Well, our domain, even though it doesn't look like it goes forever left or forever right, it actually does. It just takes a very long time to get there. And our range very clearly goes forever down and forever up. So it is all real numbers. So we have done our rational and our cubic parent functions. We know what those look like. Let's go ahead and see what they happen when we transform them. So I start with this, negative 1 over x plus 3. Let's get some points thrown in here. Because this is a rational function, I really only need 2 points. I need negative 1, and positive 1, positive 1. These are the points I really don't need. They're extra information. Now, the same thing, negative a over x minus h. This is positive or negative, plus k, where a tells us if we stretch or compress, h tells us if we move right or left, and k tells us if we move up or down. So I'm looking at this. I'm going to flip, and I'm going to move up 3. So let's do our 2 points. From negative 1, I flip, and then I move up 3. From positive 1, we flip, and then we move up 3. Now, I know we've only got 2 points on here. You're tempted to go ahead and draw a line through those points, but that's not what this is. This is not a linear equation. It is an irrational, which means that right here between the 2 points, that's where we have our asymptotes. I did not put a point here. I just circled it. I'm going to come in, and I'm going to mark our asymptotes. Notice I'm using a dashed line. Okay? It's because the line doesn't actually touch these points. And now we look to see. Well, in our parent function, we were below and above. But over here, we're above and below. That's because we flipped it. But we still follow the same rules. We're going to hug 0, come out far enough to run through our point, and then quickly try to reach infinity, never crossing that line. And over here, we're going to swoop in from negative infinity, hugging the line, come out just long enough to hit our point, and then hug 0. And so that's our graph. Our vertical asymptote, this one goes up and down. Well, that's still at x equals 0. Which means that in our domain, x cannot equal 0. Our range, well, we have an asymptote at y equals 3, which means that y cannot equal 3 for our range. So that's what we do when we have a rational function. Moving on to example number 4. We have another rational function, so -1, -1, 1, 1. The +2 means that we're going to move left 2. -3 means down 3. So start at -1, -1. We're going to move left 2, down 3. So that's our first point. Then we go to 1, 1, left 2, down 3. That's our second point. Our asymptotes. They cut the gap between our points. And now we look, well, we are below and to the left, so we're going to go ahead and shade. Well, not shade, but draw a line below and to the left. Hugging 0, hitting our point, zooming down to -infinity, swooping in from infinity, swinging out to hit our point, and then hugging 0. Our vertical asymptote is at -2. A horizontal is at y equals -3. So our domain, x cannot equal -2, and y cannot equal -3. It's very important that you mark your asymptotes. It tells you how you're going to go about doing this. Well, let's try a cubic. Again, we have a times x minus h cubed plus k, where a tells us stretch or compress, h is right or left, k is up or down. If this is negative, then we flip. So we look at this. The negative sign means that we flip. And then -5, down 5. Put our parent values in, -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. -2, -8. But then we flip, and then down 5. -1, -1, we flip, down 5. 0, 0, but down 5, because flipping does nothing. 1, 1, flip, and then down 5. And our other point is going to be too far below for us to draw. So we're going to come in. We're going to swoop in very steeply. hit our point, remain very steep, swing in, and go out. And really, this should look almost straight through this point. So, domain, all real numbers, and range, all real numbers, because it's a cubic, and those are just the domain and range for cubics. Let's try example number 6. Well, here, we're going to stretch by 2, and then left 3. Start with our default values. Go ahead and put them on our graph. -2, -8. Except we're going to stretch it by 2, which makes it -16. And left 3 is not going to help us, so I can't plot that point. -1, -1 by 2, then left 3. 0, 0 times 2 stays, but left 3. And 1, 1 times 2, left 3. And then 8 times 2 is 16, way too steep for us. And there we have our graph. Again, cubics are all real numbers for domain and range. Now on to just written statements and writing them out. We know we're going to start with f of x, and we know that we need to have 1 over x as part of our equation. I've left some room up front in case we're stretching. I've left some room in the back to move it up or down. And if I need to, I can extend this to right inside. Well, 3 units to the right, that's going to mean -3 on the inside. 5 units down, that means -5 on the outside. And reflecting means that I need to put a negative sign in front. Now for a cubic, we know we're going to start with f of x. We know we're going to have x somewhere cubed. So if I'm shrinking by 0.5, that means that that needs to go into the front. And if I'm moving up 2, that needs to go outside. And nothing was inside, so we can just leave that alone. All right, let's practice again with another rational. F of x equals, leave some room. We're going left 6, that means we're doing +6. Down 1 means -1. There was no stretches or reflections, so we're done. And the last simple statement, it's another cubic. So f of x equals, we know we're going to need the cubic function. If we move right 3, we're going to subtract 3 inside. Up 4, plus 4 on the outside. No stretching or reflecting, so there's nothing in front. And those are our written statements. Now to talk about the graphs. So, we're looking at our graph, and we see that this is definitely a rational function. So the important part here is to mark your asymptotes, because that's going to tell you how far you're moving. Well, I've got one asymptote here at 3. And I've got another asymptote here at 3. So that means that I moved right 3, which means I need to subtract 3 on the inside. I moved up 3, means we plus 3 on the outside. And we're still using 1 and 1, so there's no stretching. We're going to talk about number 12. I've got my same asymptotes. They've just been moved a little bit. One over x. Notice it moved left by 7, so plus 7. And we move down 4, minus 4. And these still in the same location, so there's no stretching, and also there is no reflections. So that was 2 rational examples. Let's go ahead and look at some cubic examples. So we know we're going to need x cubed. Well, let's take a look. Right here is our center, and if you'll notice these graphs, you can see how it gets flat so much better. But we've moved left by 3, so plus 3. We moved up by 1, plus 1. But this time we're going down, which means that we have reflected. Our next points are still just 1 away, so we know that we have not done any stretching or shrinking. If we move on to the next one, we have our center value. We move right 4, so minus 4. We move down 1, so minus 1. We're still going up, so there's no reflections. And our points still make that straight line with a slope of 1, so there's no stretching or compressing. So, this was topic 8-4. Good luck with the notes, and good luck on your assignment tomorrow. Have a good day.